Okay, finding limits graphically. Remember what the general kind of a workable definition is. It's the approximate or approaching height as you get infinitely close to an x value, to a given x value. Okay, so I'm going to stop writing that stuff down. You guys can remember that. So let's say we're going to get infinitely close to 4. Not touching 4, but we're just getting really, really, really close to 4. And if we follow that, well, we're going to get infinitely close to 4 as a height. That's all it's talking about. As we get infinitely close to an x value, what value are we approaching for the height? All right, so let's come over here. We now have a quadratic. So let's get infinitely close to -3. Infinitely close to -3. So as we're going to get infinitely close to -3, where does it run into the graph? Right there. And where is that getting infinitely close to? Well, it's actually right there, but up there at 9. So graphically, you can see that as we approach 3, infinitely close, the height will get infinitely close to that 9. Okay, and so it just continues. So we could choose a number, square root of 16, square root of x function, and let's get infinitely close to 16. Well, as we get infinitely close to 16, we're going to be approaching infinitely close to 4 as the height. So cube root, it's continuous, same thing. Not cube root, excuse me. The cubic function, x cubed, f of x is equal to x cubed, and then cube root, f of x is equal to the cube root of x. These are continuous functions. So whatever value you're approaching, you just substitute it. So if we had find the limit as x approaches 8, cube root of x, well, graphically we can see, oh, well, we're getting really close to the height of 2. But then we could also substitute 8 in for x. The cube root of 8 is 2. Then we get to graphs that are not continuous. As long as we're not approaching 0, if we're approaching 0, then the answer will be does not exist. But if we're approaching, say instead of 0, we're approaching 3. So right here, we're going to get infinitely close to 3. And as we do that, whatever height that is right there, so this is a f of x is equal to 1 over x. Well, when we put 3 in there, then the height that we're getting really, really close to is 1/3. Okay, same with the rational graph. It has an asymptote. This is not continuous, so if this were 0 right there, the limit would be does not exist. If it were one-sided, we can talk about that later. That's a little bit different situation. But as long as it's saying, hey, we're going to look to the left and the right, if we approach 0, the graph never touches one specific number. It can set it off to infinity. So you have to be really careful with non-continuous functions. But that's how you find the limit graphically.